Let's look at December 2021. We are told that on the required part, find the number of bottles that should be produced in order to minimize total costs. Then Roman 2, you find the cost per bottle at minimum price. You have 9 marks. You guys, I can tell you 9 marks are very many marks, in an exam from 41 to 50. What are we given? Coca Limited are producers of empty plastic bottles used for packing a 350 ml of Uganda Waragi. The total cost function of the bottles production is given by this function. You have the total cost function, where X is the number of bottles produced. How can you use this scenario to know the number of bottles that can be produced in order to minimize the total cost? Just imagine you're a manager, you are a production manager. Your aim is always to help the company minimize costs. It's one of your roles as a manager. How can you help the company to minimize the costs? Now, you have the cost function. This is the cost function. So the question is saying, how many, you find the number of bottles that can be produced to minimize the costs. There is a question. Now, from what we are given, the cost function, it will be really easy for us. How can you use this function to determine the number of bottles that the company can produce? So it's very easy. You simply always know that at minimum point or at a maximum point, at a minimum point or at a maximum point, the first derivative of a function is equal to 0. The first differentiation of a function is equal to 0. So when I put this, know that I'm like trying to get the first derivative. The first derivative will always equal to 0. Now, what does that one mean? This is a rule. We are going to see this practically. It's a rule. It's a rule. But as of now, just master that at a minimum point or at a maximum point, the first derivative is always equal to 0. So you are going to do what? To differentiate this. What is you're going to differentiate this. You differentiate this. So what will be your this? The first derivative? You guys, you can tell me very fast. Let's differentiate using our own rules. Just here, you don't need to apply chain rule. Just differentiate the way it is. When you differentiate, what do you get? Because here you don't have the bracket, so you just differentiate normally. You don't have the bracket, so differentiate normally. What do you get when you differentiate this? This is power 3. Sorry, this is power 3. Then this is power 2. This is power 2. When you differentiate, what do you get?
3x squared.
This will be 3x. 3x. This is 3x squared. Then minus what?
Minus 630x.
Minus minus as you multiply by 2, you get 600 what?
630x
630x. Because we are
plus
saying that you get this 2 times this, and then reduce the original power by 1. If you reduce the original power by 1, you remain with 1. Then plus what? Plus 27.
plus 27 plus
27
0.
Plus 0. Because when you differentiate a constant, you get 0. So we are saying that at a minimum point, that first derivative is going to equal to a 0. So I get this. Then I equate it with 0. Can we be in a position to solve this and get x? Can we be in a position to solve this equation and get x? Are these, or are all, first of all, are these figures, all of them, are they divisible by 3? Because you can first reduce. Are
Yes,
all figures divisible by 3? Okay, so it will be what? X squared plus what? Minus what? X squared minus
210
210x. Then plus
plus
what?
9,000.
9,000 is equal to 0. So yeah, you can use the bulldozer. Method to sort of using or from. I can say from let's say x is equal to, use the bulldozer method. Do you recall that method? This is the method. Using this, what is your a? What is your a? Your a is the figure, the first figure
Is
here. It's
1.
1. Then what is your b? Your b is
Negative 210.
negative 210. Then what is your c? Your c is 9.
9,000.
Oh, okay, we did it again. 0. Okay, this is negative 210. Then c is 9,000. So substitute in your formula and tell me the answer. X will be equal to, where there is b, I put the values. I put the values. Here I put negative. Negative becomes a plus. So I am just going to say positive 210 minus O plus negative 210. Then I open a bracket here, 4 times A. 4 times A is 1 times C, which is 9,000. Then everything I divide by 2 times what? 2 times 1. Okay? So here x will be equal to, just tell me what you have. When you deal with what you have in the bracket. Okay, just let's do this together on your calculator. Open bracket, negative 210 close bracket squared, minus open bracket 4 times 1 times 9,000 close bracket, equal signs. When the answer is on your calculator, press on the square root, then press on answer, and tell me, what do you have? After taking square root, what do you have? After taking square root, what do you have? You guys, you are quiet, eh? You guys, you're quiet. Don't say that here you are failing. What do you get?
I have 90.
90. Okay. So it means that either your x will be equal to you first deal with a positive, where you have minus or plus. You first deal with a positive. 2 times 1 you get 2. Or your x x will be where you have a positive, put a minus. Okay, so here x will be what? X will be what?
150 or 10.
150 or x is equal to 10, eh?
Sweet.
That's what you have?
60.
Pardon?
60.
Like this, eh?
Yes.
All right, so when you have two values that are positive, remember you want the value of x. You want the value of x that can minimize the cost. You want the value of x that can minimize the cost. Now here you have two values. You can't tell which one is going to help the company to minimize the cost. So in this scenario, you have to do the second step. You do here find the second derivative. Find the second derivative. From the first derivative, which was the first differentiation was what? It was this one. From this first derivative, I can get the second derivative. Now I put the two bars here. Here I can put the two bars. Then now this second derivative will be differentiate this for the second time. Eh? You differentiate this. Eh? You don't differentiate this one. Eh? Already you have differentiated. So based on this one to get the second derivative. So it will be 2 times 3, that is 6x. 6x minus what? Minus 360. Then plus 0, because when you differentiate 27,000, you get 0. Okay, so now once you get the second derivative, substitute your values. When x is equal to 150, what will be the second derivative? Someone has a question? When x is
needed.
Pardon?
Those who signs after C.
School day. What are you saying?
The signs you put after C. Are they needed?
These ones?
Yes.
Yes. Show that this is you're differentiating for the second time. It's needed. It's required. Eh? Is it okay? Because now how will the examiner know that this is a second derivative, this is a first derivative? At least you put something that can help the examiner. Okay, now let's substitute in this formula. Where there is x, put 150. So here it will be 6 times 150 minus 360. What do you get on your calculator?
270. Positive.
270.
270. Then when x is equal to 60, What will be your second derivative?
Negative 270.
Here we substitute. This is where there is x, we are putting 60. So this will be open bracket 60 times rather 6 times 60 minus 360. You get what?
Negative 270.
Negative 270. One is positive and another one is the negative. What does that one mean? Now, these figures will help you to know which one is going to help you to minimize, which one is going to help you to minimize the cost, which one is going to help you to maximize profit. Now, take note, take note. Where the second derivative, let's say this, where the second derivative is greater than 0. This shows a minimum turning point. Okay, and that one automatically implies that the value helping you to get the second derivative above 0 will be the value to minimize cost. Here, you're minimizing costs. Then where the second derivative is 0, is less than 0, it shows a maximum turning. It shows a maximum turning point, and here you will be maximizing profit. Maximizing profit. Just have that in your summary. And where the second derivative is equal to 0, there it is neutral. That is point of inflection. Point of where this one, the second derivative is equal to 0. Is equal to 0 direct. Here you will have the point of inflection. Okay. But here where your second derivative is above 0, where you have positive values, where you have positive values, the value helping you to get the positive value will be the value to help you to maximize cost. So here we are looking at a question whereby they are telling us we minimize the cost. Therefore, from the second derivative, okay, this company, from the second derivative, this company, which company? Kuka Limited. Kuka Limited. This company called the Kuka Limited. Kuka Limited should produce how many bottles that are going to help you to minimize costs? How many bottles? Which value of X gave you the minimum turning point? Which value gave us the positive value?
150.
Where you have the positive value. Then where you have a negative value, here, that one helps you to maximize profit. If you're dealing with profit, you choose that one. So it means that they should produce 150 bottles to minimize costs. I believe you will in a position to answer. Then next we determine the cost per bottle at a minimum price. The cost per bottle. How do we get the cost per bottle? Roman 2 should produce this first of all, should produce this to minimize, should produce this in order minimize to minimize costs. In order to minimize costs. Then part B, we need the total cost, the total cost per bottle. So how do you get the total cost per bottle? It will be the total costs divided by number of bottles. So do you have the total cost? Total cost is equal to what? That is the total cost is equal to what? Remember, we have the cost function. This is the cost function, the total cost function. So you substitute where there is x, you put 150. Because now you have x. This is 150 power 3, then minus 315 times what? Times this is 315 times 150 power 2. Then plus 27,000 times 150. Where there is x, you're putting 150 plus 2,000. On your calculator, what do you get? You can substitute direct. What do you get? What do you get, guys? On your calculator, what do you get? What do you get, please? So you guys, all of you are not using calculator, eh?
Let me give you my trial.
Pardon? What do you have? Me, I don't have the calculator
Me, I'm getting
here.
the figure, but it's too huge.
Until you tell me what's that figure.
Ebo, I wanted to ask.
Because you're dealing with costs. Yes, please, ask.
That one where you're saying 314 times 150. Do you square the whole thing or it's only the 150 that is squared?
It's 150 that is squared. Here.
315, not 314.
It's 150 that is squared.
And then it's 315.
This is 315. Okay, what do you have now? Here it's only x that is squared. So you square 150.
I have 339.
You have 339.
Personally, I'm getting 362,000.
500.
339, 500. Like this. Eh?
That's what I have. I don't know about others.
So finally, we need the total cost per bottle, which will be the total costs. These ones, total costs, we divide by the number of bottles, 150. What do you get, shillings?
2263.
This is 2, 2, 6, 3, 6, 3, like this. 2, 6, 3. Per bottle.
If you
Per bottle. Okay, point what? You can put point like round off to. So colleagues, that's how you are supposed to handle question. That question of December 2021. 9 marks. Very easy marks, but you can mess up when you're substituting on your calculator. And you move out saying, I passed, I passed. Just do this. Find the total cost when the output is equal to 300 units. This is also very easy. Remember, you have the cost function. And the examiner is just saying, find the total cost when the output is Q. When the Q is equal to 300. Really, is this hard? Where there is Q, just put 300 and get the total cost. That's what the examiner is meaning here. Where there is Q, just put 300 and get the answer. That is Roman 1. Are we okay on Roman 1? Are we all okay on Roman 1? I want to hear from you, I want to hear. Are we okay on Roman 1? Where there is Q, I put
Yes.
300. Then Roman 2, find the marginal cost when the output is equal to 300. Marginal cost is different from total cost. What is marginal cost? Marginal cost is the additional cost incurred for any additional unit produced. That is the meaning of marginal cost. The company has produced some products, but maybe they want to add more products. Then what will be the cost of adding every one unit is marginal cost. The marginal cost is additional cost incurred for producing any additional units. Marginal cost. Marginal cost, you differentiate the total cost function. That's how you get marginal cost. Just differentiate the cost, the total cost function. This is August 2018. The cost function, it was CX is equal to, this is our cost function. This is our cost function. When I look at these marks, these are really free marks. These be free marks, but you see people start saying, the paper was hard, what? Smiling me with calculus, we are not friends. Don't hate any topic. Don't hate any topic. The topic you're saying is hard might be the one to save you in an exam. Don't hate any topic. Just ask as much as possible to understand, but don't hate a topic. So here we need the marginal cost. The marginal cost is just the first derivative of the total cost. Marginal cost, you differentiate the cost function. So marginal cost, we differentiate. You see these questions, very easy. Differentiate, and that will be your marginal cost. So if you differentiate, what do you get? This one times 5, that is 15. 15 q power what? Q power 2, because you're reducing the original power by 1. Then plus, rather minus 20 q power 1, because you're reducing the, here it's 40. Here it's 40. 2 times, this is 2 times 20, which is 40. Then the new power will be q power 1, which is the same as q, minus the 30, the 32. Because when you differentiate this, you remain with 30. When you differentiate this, you remain with 0. Okay, so that's the marginal cost. Now, they are saying marginal cost when x is equal to 300. So when x is equal to 300, I substitute in this function to get marginal cost. So marginal cost will be where there is q, put 300, 15 times times 300 squared, times 300 squared, then minus 40 times 300, and then minus 30,000. That will be your marginal cost. And you score like how many marks? Just in very few minutes, you score your 7 marks. Roman 1, you are just supposed to get this 300 and substitute in this without doing anything, because already this is total cost function. But Roman 2, you are supposed to first differentiate. Okay, is it okay? Now we are done with this. We have answered the marginal cost, additional cost for producing additional units. Marginal revenue, additional revenue received or gained from selling the additional units. Okay, November 2019, as we wind up.
Abe,
Yes, please.
when I look at the question, I see they use Q, CQ, but on the answer you're writing X.
I'm writing X. Hey, where is X coming from? Hey, I think I just copied. It's Q. I just copied and pasted the first equation. This is Q. This is Q. Don't change. Okay, is it okay now? Let's first do this part B. November 2019, rather November 2018. Just I'm doing a lot of questions so that you be familiar with this thing. You see that these marks are easy to score. Be familiar with these questions. Part B, November question, part B. We are told to determine the output that maximizes. Now this word is very key. That maximizes the total revenue and obtain the maximum royalty. Here, what is maximized? It's revenue. Very, very key. It's revenue. At maximum point, the first derivative of that variable will be equal to 0. Now, what are you given? We are told that a famous writer of project planning at textbooks would like to be paid a royalty of 15% of sales revenue. That is royalty, 15% of sales revenue, and insists the price should maximize total revenue. On the other hand, the publishing company is interested in maximizing profit. So here you are maximizing profit. I think that is Roman 2. You're maximizing profit. The variable here is profit, but on Roman 2, the variable is revenue. These are different things. Okay. Now, given the total cost function and the total revenue function, this is total revenue function, and this is the total cost function. Can you determine the maximum total revenue and obtain the maximum royalty? So from our cost function, from RQ, are they using Q or they are using X? From RQ, since they are using Q, RQ is what? Is equal to this. From RQ is equal to this. That is our RQ. Don't know whether you can hear me. This is our RQ, our RQ. Okay. This is power 2. This is power 2. So can you get the maximum revenue? At maximum point, the first derivative of the revenue function must be equal to 0. Because here you're dealing with revenue. So deal with revenue function and differentiate. So what is the first derivative of this function? You differentiate. What do you get? You differentiate. When you differentiate this, you get 10,000. 10,000 minus what? 2 times 10, that is 20 Q. Because the new power will be 1. 2 minus 1, you get 1. So that is the first derivative. You equate this first derivative to 0. So you will say, therefore, 10,000 minus 20Q will be equal to 0. Then here, 20Q is equal to 10,000, and your Q is what? Your Q is what? When you divide by 20, your Q is what?
500.
500. But they don't need Q. They don't need the number. They don't need the quantity that can maximize revenue. They don't need the quantity. Oh yeah. They need determine the output. Oh yeah. Since they need the output as well, they need the output, not the maximum total revenue. Then that is your output. Q is equal to what you have there, 500. So 500 will help you to maximize 500 will help you to maximize revenue. Now, what is the maximum royalty? Remember, royalty is 15% of sales revenue. Maximum royalty will be the 15% times total sales, because that's what they gave us. That's what they gave us. But what is the total sales? Total sales is equal to what? From your function, this is total revenue, total sales. It's this. Total sales. Where there is Q, put what? Put 500. So this will be 10,000 times 500 minus 10 times 500 squared. What do you get? As your total sales?
$2.5.
Pardon?
2.5
2.5. 2.5 only, or 2.5 million.
million.
All right. 2.5 million. So that is total revenue or total sales. So it means that maximum royalty is equal to 15% times 2.5 million, which gives you how much?
$375,000.
375,000. And you have your 5 marks. Just now, where is it? Where do you find issues? Someone who says QT is hard. Where is the issue? These things are not hard. Roman 2, Roman 2, Roman 2, Roman 2, Roman 2. What do we need? Roman 2, we need the output that maximizes profit. But do you have profit function? Do you have profit function? You don't have profit function. You have revenue and cost. So how do you get profit? First of all, how do you get profit? Profit is equal to total revenue minus total cost. Total costs. That's how you get the profit. So you have the profit. Here I'm going to give you two methods. You'll choose the one that is easy. Total revenue function is what? Total revenue function is this one. This is total revenue function. So you have the total revenue function, then minus open bracket. Minus open bracket. What is the total cost function? Total cost function, it's this one. This is the total cost. This is the total cost function. This is power 2. This is power 2. Only. Okay. So when you open bracket, you see what I'm doing. Total cost function, I'm putting it in bracket. Why? The negative will affect whatever is in the bracket. That's where students make errors. So this will be This will be this one. We are opening bracket now. When we open a bracket, this one will be minus 1,000 minus, because negative times positive, you get negative 2,502. Then minus 5q squared. 5q squared. Collect like terms together. You can start with the highest power. So here it will be the highest power. It will, okay, you just try to correct like terms. The highest power is negative 10, negative 10. Okay, you can do it at once. You have this. You also have this. In total, what do you get? Negative 10 minus 5, what do you get? Isn't it negative 15? Negative 15q squared. Negative plus negative, the negative increases. So it's negative 10 plus negative 15, which is rather negative 10 minus plus negative 5, you get negative 15. Get 10,000 minus 2,500. What do you get? That is 75?
7,500.
500 Q. Then minus 100, minus 1,000, okay? So this is your profit function. This is your profit function. But to maximize the profit at maximum, the first derivative of the profit function, will be equal to 0. But do you have the first derivative? Someone has a question? So the first derivative, let's differentiate this. This will be a negative 30q plus 7,500. So it means that when I put in my formula, this one will be equal to 0. So yeah, it's negative 30q is equal to negative 7,500. So my Q, the one that can help me to maximize profit, my Q will be negative 7,500 divided by negative 30. What do you get? What do you get? What do you get?
250.
Pardon?
250.
That is 200. So that is here the company needs to sell 200 textbooks to maximize the. You guys, you get 200.
250.
Guys, you giving me wrong things, eh? Pardon? What do you get?
250.
So a company needs to produce, rather to sell. The company needs to sell these number of textbooks for them to maximize the profit. Then here, what will be the maximum royalty? The maximum royalty will be 15% times sales. It's not times profit. So you will need to know what is total sales. Total sales when Q is equal to 250. You first get total sales when Q is equal to 50. From this revenue function, you get the total revenue, total sales will be equal to what? You substitute where there is Q, I put 250. Then where there is here Q, I put as well at 250. So there you will get your total sales. After getting total sales, substitute in this one. And you have your how many marks? These are clean marks, guys. These are clean marks. 11 clean. Okay. Okay. Let me explain it. I don't want to over spoon feed you. Let me explain it here. You go and do it. Then you show me what you have done. So here you have the cost function. You have the cost function, and you have the price function. This is the price function. This is the price. The price at which. This is the price function. They are telling you find the marginal cost. How do you get marginal cost? You differentiate the marginal, rather you differentiate the cost function. That's how you get, the marginal cost function. Now, how do you get the revenue function in this case? How do you get revenue function? Because you're given a price function, to get revenue function, revenue is equal to price times quantity. So put the price function here. I put the price function. Put the price function this one. You put the price function where there is P. Where there is P, you put the price function. Where there is P, you put the price function. Where there is P, you put the price function. You put the price function. You put the price function, that is where there is P. So you put the price function, then times whatever you get multiplied by Q. By 2, because you're trying to get revenue function from prices, from revenue is equal to price, selling price times the quantity. This is total revenue. Total revenue. So you're going to get the total revenue function. So when you open a bracket, your revenue function will be a third. Will be a third. A third times what? A third into 75Q minus Q squared. Because when you open a bracket, that's what you get. When you get Q times 75, you get 75Q. Q times Q, you get Q squared. So this is how you are supposed to get revenue function. Now you have revenue function, you have total total cost function. That one was given direct. That one was given direct. This is the what? This is the cost function. Now, to get marginal cost, you differentiate this function. Only you differentiate this. Then marginal revenue, you differentiate the other function. You differentiate the other function. But because they want the marginal cost and marginal revenue, they don't want the functions. What you do, you go ahead and after differentiating, after getting marginal cost function, you equate it with get marginal cost function, then you differentiate this to get your marginal revenue function. Equate and look for the value of Q. After getting the value of Q, substitute in your marginal to get your marginal cost. Substitute in the substitute Q in your marginal cost function. Then to get marginal revenue figure, you substitute in the marginal revenue function. Just like that. So I believe you'll be in a position to do that. Please you do, and also do this one, part B. Part B, you need the maximum profit, the Q that can maximize profit. You were given the cost function and the revenue function. I believe this we have already done this. Then hence determine the maximum revenue attained when the level is at maximum. But here you need the profit function, revenue minus cost. Okay, so you do that, don't do this. Don't do this. Do that. That is your assignment number 1. Also do this. Also do this. This part, you do this December 2020 part C. Don't do this. Leave out that part A, rather part B. I just do these 9 marks. This is the profit function. Here you're given the profit function, and they are telling you determine the one that can maximize the profit. The one that can maximize profit, you have to differentiate, because they have not said when this is equal to 0. They have not said when it is equal to 0. So you have to first differentiate. The answer you get, you say at maximum profit, the first derivative of profit is equal to 0. So you will be in a position to get the answer. Please do this one and this one. I believe once you do those ones, you will be good to go. You will be good to go. Okay, that's enough for now. Let's meet next time.